So please welcome Vadim.
Hello, everyone. I would like to make lightning talk about dependency injection. First of all, we use an extremely modified version of deep library with IP changes, different optimizations, and additional functionality. A bit of history. Initially, our iOS project was a big monolith, one huge binary. On a slide, you can see a connection between Viper's models. It looks like this. Now you understand full image. And we have some problems with this scheme because the large binary compiled from more than 2,000 of files, and it was very slow because it's compiled only on one core. And we also have some problems with IDE and some conflicts in project files. And the most painful things is the incremental build didn't work. And also we have some strategy for our project. We want that our project should be scalable. We want reuse functionality between applications. Also we want some impact analysis and code ownership. And the main goal is make our developers happy while they work on our project. And the answer is a modularization of our project, and it looks like this. It's a feature, models, mediator, and core layer. And we just split our monolith on these layers. The main rule for receive benefit from parallel compilation is the feature shouldn't depend on each other. And mediator should be lightweight and compile fast. How to feature communicate between each other? For this, we use dependency injections. We have some container, and feature can register implementation and put it on container. Then another feature when want some impl, it get container from mediator and just get impl from container. That's all. And some sample of code. Here we register some service and then just resolve it. It's simple. We use closures here. And about testing. How to test this solution? Here code generation help us because we can be sure that we have full code coverage. You need to activate all registration and resolve, and then check the full compliance for it. Some additional features. It's lazy resolve, lazy register, and a lazy framework load. I'll start with lazy resolve. It works like lazy Swift property in Swift, but has a log for synchronization for multi-threading. It's a simple wrapper. Let's move. Lazy register. We have made a special class that provides case and definitions for finding a factory and finding the instance that can be lazy register and resolved. Let's look on the scheme. We try to resolve something from container. If it's success, we just return it. If not, we find provider by key and then try to load framework. If success, we register all definition from factory and then resolve. If not success, we load framework like in previous presentation and then register it. And also we have some special tool. It's called warming up. After displaying the first content, we call warming up, which load unnecessary at the application start code. And it's reduce time for open another screen. And some advice for make sure that you're safe. It's be sure that you have a full test coverage. You should have a performance test and metrics. And of course, you should have a real-time monitoring for Cs that work correctly. That's all.
Brilliant. Thank you very much, Vadim.